Hello, students. Good evening, good afternoon, good morning, depending upon the time of the day. How are you all? I'm sure you all are doing great and you're gonna be great, right? That's the punchline that I'm having. I'm still working on that. What will be my intro, right? So, you all are great, I'm great, everyone is great. We all must have this positiveness, right? So, with that positiveness in mind, let's start our video or the lecture, right? Great. Now, what we have done in last class? In last class, we have started with slope, right? So, we have kept a very small lecture. It was very late at night, so the lecture was around 20-30 minutes only, between 20 to 30 minutes. Anyhow, we have done a very important thing. We have introduced slope, and believe me, you will get to know how important slope is in physics because it is used in almost every chapter, right? So we have talked about slope, what exactly slope is, how exactly we define slope mathematically, and what is the difference of a slope, what is the difference between slope of a straight line and slope of a curve, right? That part we have seen. Clear? So slope of a straight line is constant, slope of a curve is variable. And we have also discussed how difficult it is to find slope of a curve. And at whichever point you want to find the slope, you have to draw a tangent, measure the angle, find the tan of the angle theta, and that becomes very, very difficult. Now, this leads to the introduction of differentiation. So differentiation is a tool which is going to help us in finding slope of a curve in a very easy manner. That's the biggest application or the biggest use of differentiation, right? So what exactly differentiation does, right? Let me start here. So differentiation basically gives us slope, and just keep this in mind. Differentiation basically gives us slope. So differentiation is nothing but differentiation, right? Differentiation is represented in general by dy by dx. Okay, in general we represent by dy by dx, and this dy by dx, let me write it in a different way with a different color because I want to emphasize on something. So differentiation is nothing but dy by dx, right? And this just gives us the slope. Differentiation simply gives us the slope, right? Now here you must if you can observe here I have written something in red. So in short, we write it as dy by dx. You don't have to write in different color all the time. I have done this just to make you understand a certain concept, right? Dy by dx. So in general, this is how we represent. But this d by dx that we have, whatever I have written in red, is called as operator symbol. Okay, this d by dx that I have written is called as operator symbol. What is an operator symbol? Right? This is nothing but your operator symbol, right? What is that supposed to mean? So I have told you in last class, differentiation is similar to addition, multiplication, subtraction, or division, and you have learned these concepts. You have learned differentiation, multiplication, subtraction, and addition, and we know that we cannot solve any question without those mathematical operations, right? So same way, differentiation is also a mathematical operation which we will be needing a lot in solving questions going forward in physics, right? So similar to how you have symbol for multiplication, division, like for multiplication you have the symbol, for division you have the symbol, for addition you have the symbol, for subtraction you have the symbol, right? So these are nothing but operator symbol. For example, if I write y into x, what does that mean? Y into x means you have to multiply x with y or y with x, anything you can say. Or I can write y divided by x. So this means that you have to divide y by x. If I write y plus x, this means you have to add y with x. Or if I write y minus x, this means that you have to subtract x from y. Yes or no? So if I keep it in a similar manner for every example, this means you have to multiply y with x, this means you have to divide y with x, this means you have to add y with x, and this means you have to subtract x from y. Fine. So similarly here, this operator symbol tells you that you have to differentiate y with respect to x, right? So in short, we write like this. So what this symbol is telling you, this is telling you that you have to differentiate. So this d by dx that we have, right, you understand now, this d by dx is operator symbol, and it tells us that you have to differentiate y with respect to x. That is what this symbol means. And when you perform this differentiation, right, like how will you do multiplication of y with respect to x, or how will you do division of y from x with x, right? So we have learned certain rules, right? You have learned certain ways or certain methods in how to multiply, divide, add or subtract. So same way we have to learn how we can differentiate any function y with respect to x, or how we can differentiate any function in general, right? So similar to how you have learned addition, multiplication, division, subtraction throughout your life, same way we are going to learn how to differentiate any function, and we are going to use differentiation in coming topics, right? I hope you are following me. You are with me right now. Yes or no? Great. So with this spirit, we'll go for the next part now. So our goal now is to understand how exactly we differentiate any function, right? You know how to perform these mathematical operations. Now we have to understand how exactly we are going to differentiate y with respect to x, right? Great. So the thing is that we are not going to go in depth here, because you have this calculus part in maths as well, and there you will be studying things much more in detail. So what we are going to do now here, we are going to learn how to differentiate, and to learn how to differentiate any function, there are actually set of formulas. So depending upon the kind of function that you are trying to differentiate, there are certain fixed set of rules or formulas are there that you have to remember for now. You will understand how exactly we get those formulas in mathematics. We use limits and the concept of the first principle to derive those formulas. Those derivations are not at all important in physics. That we'll be studying in maths. Here we'll just understand how to differentiate any function with the help of certain set of formulas, right? So now what we are going to do, we are going to see the important differentiation formulae that we use in physics, and side by side we'll be taking some examples as well, right? Okay, let us start. So the heading will be differentiation formulae. So let me put the heading in yellow. That will give you a clear picture, clear demarcation here, that this is the heading, right? So the next heading is differentiation formulae, right? Awesome, right? Formulae, formulas, both are fine, okay? Both are plural for formula, right? So let us see the very first formula, okay? So if you have, so as I told you, see, we are differentiating y with respect to x, but eventually y will be a function of x. Like y could be a exponential function, y could be a power function, it could be a trigonometric function, it could be a logarithmic function. So depending upon what kind of function it is, we have different set of rules or formulae, you can say. So the first one is, suppose if you have y equal to x to the power n, right? Suppose if you have a function which is in the form, which is a power function like y equal to x to the power n, where n is any real number. What is n here? N is any real number, right? I am sure you know what is real number, right? Real number in the sense, this n could be anything except imaginary number. In the sense, n could be an integer, it could be a positive integer, negative integer, it could be a fraction, it could be a decimal, anything is fine. It just should not be any imaginary number. What is imaginary number? You will study about them in maths. And under root of minus I, that comes under imaginary number. So especially like under root of negatives, square root of negatives are imaginary number. But we are not going to go in that again. So n can be anything, your integer, whole number, fraction, decimal, anything is fine. Clear? It can be 1 by 2, 1 by 5, plus 5, minus 10, minus 9 by 4, minus 9 by 8, plus 9 by 5, anything you can think of. Just that it should not be any imaginary number, right? Is that clear? Okay, moving ahead. So now if you have any function in the form of y equal to x to the power n, then its differentiation is given by the formula dy by dx becomes nx to the power n minus 1, right? So very simple but very important formula, right? So if you have a function y equal to x to the power n, its differentiation becomes nx to the power n minus 1. right? So how to apply this formula? For that, we'll take a couple of examples. So let us take a very basic example first, right? So suppose if you have y equal to x cube, simple basic example I'm taking. Suppose if you have a function y equal to x cube, and then you need to figure out what will be differentiation of this x cube, right? Fine. So if we differentiate this dy by dx, right, dy by dx, that becomes, we'll apply this formula here, right? So compare with this general expression. Here you have y equal to x to the power n. What is the power of x here? What is the power of x here? 3. So if we compare, n here will become 3. So for this particular expression, n is 3, and if I apply this formula, nx to the power n minus 1, that means it will become 3 into x to the power 3 minus 1, right? How much is 3 minus 1? 2, right? Great. So finally we are going to get the answer as dy by dx will come out equal to 3x square. So as simple as that. So this becomes the differentiation of x cube, right? So one thing I actually forgot to tell you, in the flow. So we learned, we got to know that differentiation helps us in finding the slope. So how exactly it is going to help us in finding the slope? So let us understand this with this particular example itself, right? Suppose you have y equal to x cube. So y equal to x cube will represent some sort of a curve, yes or no? So y equal to x cube is an exponentially increasing function in a way, means as x increases, y will also be increasing. So roughly if I plot a graph of y equal to x cube, the graph will be something like this. This is how the graph of y equal to x cube will look like. It will not be a parabola, because for parabola the equation should be quadratic. This is not quadratic, but still it will be an increasing function, something like this, right? Now suppose this is the graph of y equal to x cube. So only thing is that if you want to find slope with the help of differentiation, you should know the equation of the curve. And if you have the equation of the curve that is being given, then you can use differentiation. If they have drawn it geometrically, then obviously you cannot find with the help of differentiation. Or if they are given some hint, some data is given, the first thing that you have to do is you have to write the equation of the curve. And if it is a straight line, or it's a parabola, or it's a sine function, you can write the equation or the function for that, which is very simple. Once you learn mathematics, you can write equation for any function in general, right? So this is the curve, and we know its equation already. The function or the equation of this curve is y equal to x cube, right? Now suppose you have to find slope at x equal to 2, and suppose there's a certain question where you have to find the slope of this curve at x equal to 2. Now what do you know? If you try to do it with a normal geometric method, things will be very, very difficult. Like if you want to find slope at x equal to 2, the first thing that you have to do is you have to draw a tangent on this particular graph corresponding to the point corresponding to x equal to 2, right? So here you will draw a tangent and then find the tan of the angle of the theta that this tangent makes with positive x-axis, right? But we are using differentiation, so we are not going to do all that. I don't even need to mark all this, not required, not at all required. So what we are going to do now is, when you differentiate any function, what you get is actually you get slope as a function of x. So very simple thing you need to do. We had the function y equal to x cube, right? So when you differentiate, when you do dy by dx, dy by dx is simply going to give you slope as a function of x, right? So this particular point is also very, very important. So we have this function y equal to x cube. When I differentiate, I get another function, right? We saw here. When I differentiated this, I got another function 3x square. So what exactly this function gives us? So this very function, dear students, is simply slope as a function of x. It is simply slope as a function of x. What is that supposed to mean? So this was your original function. This is the original function that you have, y equal to x cube. And once we have differentiated it, we get slope as a function of x. And what is that function? We have already done the differentiation. So that is 3x square. So the function is y equal to x cube. Slope will be given by 3x square. Now things are very, very simple. If you need slope at x equal to 2, you have to simply put x equal to 2 in this particular function. As simple as that. No need of drawing tangents, calculating angle, finding tan theta and all. You have to simply just put the x coordinate of which you want to, at which point, the point at which you want to find the slope. If you want to find slope at x equal to 1, simply put x equal to 1 here. If you want to find slope at x equal to 2, you simply put x equal to 2 here. Yes or no? As simple as that. So if I need slope at x equal to 1, then I'll just put x equal to 1 in this function. This is your slope as a function of x. Let me draw a box here to emphasize its importance, right? So if I put x equal to 1, how much will be the slope? 3. 3 into 1 square becomes 3. If you need slope at x equal to 2, then what you have to do? All you have to do is just put x equal to 2 in this particular function, right? Let me put a bracket here, otherwise it creates confusion, right? So if I simply put x equal to 2 here, what will you get? 3 into 2 square, that becomes 12, right? So now some of you might be having confusion. Can slope be 3, 12, 19, 14? It can be anything. Why? Because the range of tan theta varies from 0 to infinity. So for standard angles, you know the result, like tan 30 degrees 1 by root 3, tan 60 degrees root 3, tan 45 degrees 1. But if you could have angles other than those standard angles, right? You can have tan 70 degree, tan 72 degrees, tan 80 degree. So those can have higher values as well. You can have 3, 12, 13, 14, 19, 100, 1000, 2000. Any number is possible between 0 to infinity. So yes, slope at x equal to 1 will be 3, x equal to 2 will be 12, right? I'm sure you're understanding now. See how easy it becomes now. Earlier, if I had to find slope at x equal to 1, I have to draw a tangent at x equal to 1, then find the angle, find tan theta. That's very lengthy process. Yes or no? And one interesting bit of information I'll give you. This calculus, this differentiation and integration was invented by Newton himself. Yes or no? So the very own physicist who has given most of the important laws in physics, he also invented the required maths to solve those physics problems. Yes or no? Isn't that interesting? Right, great. So moving ahead, so you got to know, you differentiate, you get slope as a function of x. At whichever point you need slope, just put that particular point and you will get the slope value, right? So we need to see a few more examples. So the idea here is, now first we need to understand how to differentiate different functions. So I'm not going to waste much time here now in oversimplifying things. Let's go for the next example, right? Okay, that's great. Fine. So example 2, let's take another simple example now. Suppose if you have y equal to root x. And these are some standard examples which you will come across very often while solving problems. Suppose if you have y equal to root x, right? Now how do I differentiate this? First thing is, if you have any function, if you have any power function, you have to first write it in x to the power n form. So right away when I look at this expression, I may not be able to differentiate right now. But if I write it in x to the power n form, I can easily use the formula that we just studied. So how can you write root x? Root x is nothing but x to the power 1 by 2. Yes or no? Right, root x is nothing but x to the power 1 by 2. Great. Now we are going to differentiate this. I just need a little bit of water. Okay. Sorry, just a moment. Okay. Right, great. Fine. So now you can compare this with x to the power n. So if you compare this with x to the power n, n here will be 1 by 2. So what will be the differentiation then? So the differentiation dy by dx will become nx to the power n minus 1. Here n is 1 by 2. So we'll put the complete 1 by 2 as it is. It's not, 1 is not your n or 2 is not your n. That complete 1 by 2, the complete fraction, the complete decimal, the complete negative integer, positive integer, whatever is there in the power, that is your n. So it becomes nx. So 1 by 2 into x to the power 1 by 2 minus 1, right? So this becomes 1 by 2 into x to the power minus 1 by 2, right? So this here your differentiation is done. But you know, sometimes in options they may not give the option exactly like this, because you know any mathematical term can be written in different ways as well, right? I can write this x to the power minus 1 by 2 as 1 by, means 1 by 2 is already there. So I can also write it as 1 by 2 into x to the power 1 by 2. Yes or no? Or we know that x to the power 1 by 2 is root x. So we can also write it as 1 by 2 root x. So mostly this is how they will give the expression in the option, not like this or not like this or not like this. Most of the time they'll give you like this. So you should know that you could write this in this way as well. It's a simple maths, but in the beginning students do get confused, right? Great. So if you have y equal to root x, its differentiation is 1 by 2 root x. If you want, you can also remember this result because this term comes very often while solving questions, right? Great. Let us see a few more commonly asked expressions based on just this simple formula. So now you could have an expression like y equal to 1 by x, right? You could have an expression like y equal to 1 by x, right? Now I'll give you some time. Take a moment or two. You can pause the video if you want and tell me what will be the differentiation. I have to just check something. Right, great. We are doing great. We are going super strong. Fine. I hope you all tried. So let me do it for you now. So we have y equal to 1 by x. How do I differentiate y equal to 1 by x? So 1 by x can be written as x to the power minus 1. You can write 1 by x as x to the power minus 1. Right? Clear? Y equal to 1 by x becomes x to the power minus 1. So now we have to differentiate. How do I differentiate? So for differentiation, what you do is you compare this you compare x to the power minus 1 with x to the power n. And if you compare with x to the power n, what will get? We'll get it becomes nx to the power n minus 1. If you compare x to the power minus 1 with x to the power n, n will be minus 1. So if you differentiate, it becomes minus 1 into x to the power minus 1 minus 1. What is minus 1 minus 1? Minus 2. Simple. So it becomes minus x to the power minus 2. Again, you can further simplify it. It can be written as minus 1 by x square. Right. So again, these are some standard examples that I wanted to share with you. Fine. So if you have y equal to 1 by x, differentiation becomes minus 1 by x square. So that's the point you can keep in mind, right? Okay, great. Let us see the next part. Okay, now, so similarly, if you have any algebraic expression which you can write in x to the power n form, you can use this particular formula, right? Okay, let us see. Let us see the next example. Next example is, no, we'll not see the next example. We'll go for the next formula now, right? So we saw y equal to x to the power n. The second formula is y equal to c, which is just a constant. Or I'll write y equal to constant. Or y equal to c also they write some places. Fine. Right. So if y is any constant in the sense it can be 1, 2, 3, 4, 2 by 5, 9 by 10, minus 10 by 12, any constant you say. I'm sorry. If y is any constant value, then its differentiation, what will be the differentiation? Differentiation will become 0. Fine, dy by dx here will be 0. That is the thing. Fine. So this formula you can understand by intuition. I'm not going to derive it, but this we can understand actually, right? Suppose if you have any function which is a constant function, right? We can understand with the graph how the differentiation becomes 0 here. Like suppose if I give you a function y equal to 5, right? If I give you a function y equal to 5, so how will be the graph of y equal to 5? And how will be the graph of y equal to 5? So y equal to 5 graph will be simply a straight line. Y equal to 5 graph will be simply a straight line parallel to x-axis. Yes or no? Y equal to 5 is going to be a simple graph parallel to x-axis. So now since this graph is parallel to x-axis, how much will be its slope? How much angle it is making with x-axis? This graph is parallel to x-axis, so theta here is 0. Theta here is 0 degree. The angle that the straight line makes with x-axis is 0 degree. So tan theta will also be 0. So slope here will be 0. Yes or no? So, and we know that differentiation gives us slope. Differentiation gives us nothing but slope. So here if slope is 0, differentiation will also be 0. Right? Clear? Great. Understanding? Any problem here? Okay, let's go for the next one. Right. So next we have, if you have y equal to constant. Now, so if you have y, if y is some constant, differentiation will be 0. You can take some examples. One example I already took here. Like if y is 5, if y is equal to 5, how much will be the differentiation? Differentiation will be 0. Right? Clear? Another example, if I give y equal to e, then what will be the differentiation? Right? What will be the differentiation here? Y equal to e. E is again a constant only. E is also a constant. E is nothing but a mathematical constant. Right? So a mathematical constant is also a constant. So whether it be e, pi, anything, again the differentiation will be 0. Right? Another example, if I take y equal to pi, what will be the differentiation here? Here also differentiation is going to be 0. So I'm sure you understand. So if you have any constant, be it negative, let me take a negative example as well. Suppose if y is minus 1 by 2 pi, right? Negative is there, pi is there, anything, anyhow, this complete expression is a constant. Since it is a constant, differentiation is going to be 0. Differentiation is going to be 0, right? Don't need to put this, draw this box in. Right, so here what will be the differentiation? Differentiation will be 0. Amazing. Right, now let us see one last formula for this lecture. So see, it's a long topic, there are a lot of formulas, and we are going to do in a good manner, in a slow paced manner, trying to cover most of what is required. So whenever you are in need, you can revise. I'll put everything in a playlist. You can go one by one and skim through all of them. Right? Okay, great. So next we have, if y is some constant c into x to the power n. If y is some constant c into x to the power n, like 5 into x to the power 3 or 2 into x to the power 5 or something like that, then what will be the differentiation? Right. Now this is a place where you have to be very, very careful, and this is where students get confused also. Now some of you might say that since c is a constant, the differentiation should be 0. See, if you have a constant alone, like y equal to 5, y equal to 5 is a constant function, but y equal to 5x cube, is not a constant function. There 5 is a constant in multiplication, but as x varies, the function is going to vary. So y equal to 5 is constant, differentiation will be 0, but y equal to 5x cube is not a constant, that is from all the sides a variable function. So differentiation of y equal to 5x cube is not going to be 0. So keep in mind, whenever a constant is in multiplication with a variable part, then the differentiation will not be 0. That constant remains as it is, and you just differentiate x to the power n. And differentiation of x to the power n will become nx to the power n minus 1. Right? What will be differentiation? Nx to the power n minus 1. Clear? Understanding? Great. Amazing. Fine. So what will be the answer here? No, so this is the formula. So now if I can take some basic examples, right? We'll start with the very basic ones. If y is 5x cube, what will be the differentiation? Simple, very simple. Here 5 remains as it is in multiplication. Differentiation of x cube will become 3x to the power 3 minus 1, which is 2. So that will become 15x square. Right? As simple as that. Another example, if I take, if y is minus 2 by x cube, what will be the differentiation here? So here minus 2 is the constant multiplication. We can write it as minus 2 into x to the power minus 3. We can write it as minus 2 into x to the power minus 3. So what will be the differentiation here then? The differentiation dy by dx will become minus 2 into minus 3x to the power minus 4, like that, right? So finally, if you simplify this, the differentiation dy by dx becomes 6x to the power minus 4, right? Clear? Okay, if you want, you can further simplify it. You can write this as a 6 by x to the power 4. That is up to you. Yes or no? Another example, if I take just a simple example, if y is root x by 2, right, then what will be the differentiation? So here the constant in multiplication is 1 by 2, so it becomes 1 by 2 into x to the power 1 by 2, right? It becomes 1 by 2 into x to the power 1 by 2. So now you differentiate this. If you differentiate this, what are you going to get? Again, 1 by 2 is a constant, it remains as it is in multiplication. Next it will become 1 by 2 x to the power 1 by 2 minus, and x to the power n minus 1. So we already know, right? We can use the result as well. We know differentiation of root x or x to the power 1 by 2, that is 1 by 2 root x. If you differentiate root x, upon simplification it becomes 1 by 2 root x. So that will become 1 by 4 root x, as simple as that, right? So I hope you understood how to apply this formula y equal to c into x to the power n, right? So for this particular lecture, we'll keep it till here. So keep practicing, keep learning, keep growing, keep supporting, right? Okay, great. So I'll end this session here. We are going to continue this in the next lecture, right? Okay guys, good night, good day, good evening. Enjoy your rest of the day.